Alright, starting lesson 4.5, dilations. Alright, so what is a dilation? Alright, it's a type of transformation, but with this type of transformation, the figure is being enlarged or reduced. Okay, so for the other transformations, translations, reflections, rotations, those are rigid transformations, right? Because the shape of the figure doesn't change. Now the shape of the figure is going to change with dilations. All right, so you could go ahead and read through this. And there's quite a bit of information to process there. But here's the basic idea. All right, you have this smaller figure, and you're enlarging it, in this case, to a bigger figure. All right, and all the angles are the same. All right, the angles are the same. All right, but with the side lengths, there's a scale factor. Okay, and this is the important concept here, this scale factor idea. All right, so here we have CP, or CP prime, over CP. Okay, so remember this, whenever you're setting up your scale factor, it's the image length over the pre-image length. All right, and I'll emphasize that idea once again in the next example. All right, now if your scale factor is greater than 1, all right, the figure you originally started with will be enlarged. If your scale factor is between 0 and 1, then your original figure will be reduced in size. All right, so let's go into a concrete example here to see what we're really talking about. So for example 1, it says to find the scale factor of the dilation. Then tell whether the dilation is a reduction or an enlargement. Okay, where is our P prime? Right here. That's our image. All right, so we go with the image. In this case, that side length, the image side length, which is CP prime here. In this case, that's 12. And we put it over the pre-image, what I originally started with. All right, and that's 8, CP. And that reduces to 3/2. And 3/2 is also 1.5. All right, so since it's greater than 1, it's going to be an enlargement. Well, we originally started with this triangle right here, and we ended up with this bigger triangle here, or a bigger paper clip, if you want to look at it in that way. All right, going to part B, where is our P prime? Right here. All right, so this is our side length we want to start with. So we have 18, all right, because that's our image, over the pre-image. Our pre-image, just P, that's what we started with, that's 30, and that reduces to 3/5. And 3/5 is equal to 0.6, all right, and that's between 0 and 1. All right, so the image is a reduction then. Okay, so we started with this bigger paper clip, or this bigger triangle, and then we ended up with a smaller triangle, or a smaller paper clip. All right, let's go over some other concepts. Okay, so expanding on the idea of dilations, now we're applying it to the coordinate system. And if you look at this rule here, the basic idea is if your scale factor is k, then you're applying k, or multiplying it, against x and y. Alright, so let's see how this works out in an example. Once again, still a concrete example. So graph triangle ABC with vertices, and its image after a dilation with scale factor 2. So all you're doing then is multiplying every value for x and y by 2. Alright, and that's what we have here. And what that does is it enlarges the figure. So this is what we originally started with, and here's our new figure. Alright, let's do another example. Alright, so for example 3, here we're multiplying by a scale factor of 1/3. Now 1/3 is less than 1. It's between 0 and 1. So it should be reducing the size of our figure. Alright, so we take all of these points, and we multiply the x and y's by 1/3. And we get our new points. So here's what I originally started with. And this is what I end up with, a smaller figure. All right, so that should make sense. All right, let's do another example. All right, here's another big idea. Whenever you multiply by a negative scale factor, it rotates the figure 180 degrees. Okay, so let's do an example of that. Here I'm multiplying by a scale factor of -1/2. All right, so two things should happen then. Because the scale factor is between 0 and 1, in terms of its actual value, all right, just a half, all right, that means the figure is going to reduce in size. But since it's negative, that means the figure is going to rotate 180 degrees. So here, if I take this point here, it's going to rotate 180 degrees over here. But the figure is also reducing in size, once again, because I'm multiplying by 1/2. So I started with this figure, and then I end up with the figure that's rotated 180 degrees, and it's smaller than what I originally started with. All right, so there's not much to that. And the last couple ideas. All right, for example 5, you're making your own photo stickers. Your photo is 4 inches by 4 inches. The image on the stickers is 1.1 inches by 1.1 inches. So this was your image. All right, remember we always start with the image on top. So we're going to do 1.1 over the length of one of the sides from the pre-image, which is 4. All right, and I don't like having decimals and fractions. So whenever you end up with a situation like this, you just shift the decimal over 1 here, and you're going to take this decimal and shift it over 1. So essentially I have 11 over 40. And there's your scale factor for that. Pretty simple. All right, for the next one. Okay, for example 6, you're using a magnifying glass that shows the image of an object that is 6 times the object's actual size. Determine the length of the image of the spider seen through the magnifying glass. Okay, so the image length we don't actually know, but we know the actual length of the spider is 1.5. All right, and the scale factor is supposed to be 6. All right, so just doing basic math, we multiply by 1.5 on both sides. Cancels out. 6 times 1.5, x equals 9. That's the length of our image. All right, and that's all there is to dilations. All right, we're done with the chapter now. If you have any questions, please make sure to ask. Begin the assignment.